This is not so time critical.
500 millimeter diameter centrifuges.
Interesting.
It's not aggressive, so we all know there is no need to introduce Vladimir. So, Vladimir, the floor is yours.
Okay, that's the tool number 1. This is the tool number 2. And this is the connection that is required to record what the hammer is doing. Salt is being prospected for example, in Namibia at Cape Cross. This is a small drilling system to take core samples from underground. Okay, here are the core samples. Sand first, 1/2 meter. Then there is some salt. After that, there is some mud. Then there is salt again, mud, and this is 15 meters. It takes several days. We were approached by company ATS, who asked, look, we are looking for all kinds of things underground, for example, water, and we found out that we can also find oil and gold. And of course, when he said gold, well, I said, yes, of course, we will try. We will try it with salt, whether we can do something with salt. And then they, well, we started looking for where we could try it out. And we are extremely grateful to the Swiss Salt Works that they have allowed us to test this method in their salt deposits that are in Riburg. Those of you who are coming on Friday to see the Swiss Salt Works and Riburg, you will see the field where we have tried out. Actually, the logo of this meeting here, the blue one, is taken, the photograph of that is taken exactly where we have done this mapping. Now, the principle of this is that if you have a grain of rock, then this grain of rock is negatively charged and it attracts cations. And the cations form a layer, and the second layer, which is not so strong. Now, when this is hit by the seismic wave created by this on a piece of plate, I didn't bring the plate is on our stand, you can take a look at it. Then the seismic wave propagates down to some kind of geological formation. And this geological formation reacts to the pressure by creating electromagnetic wave. The electromagnetic wave is created by the cations, not by the rock. Okay? But depending on what rock it is, whether it's a sandstone, whether it's some gravel, whatever, the electromagnetic wave has a certain profile. There is another type of response, which is the Electro-Telluric response. where the pressure head wave is traveling along some surface, some geological surface, and is creating electrical field, which again is propagating towards the top and can be then recorded by the antenna. That's this and this. This is the recording. These are the tools that are required. I have taken just the 3 of them. This is the place where we have tried it out. Here is the salt works where we are going on Friday. This is the River Rhine. The yellow line is the boundary, is the frontier between Switzerland and Germany. And this is the field that we have selected. This is about 660 meters and it's about 200 meters wide. It has been used for solution mining since centuries. There are still some of the original boreholes there. You will see them on Friday. Again, this is the field. We have selected about 30 points there. And by the way, there are 3 solution mining wells there, boreholes, that are still operative, and several others that are no longer operative. Well, it was hot, it was in June, and of course I have to try everything I do. I mean, I just can't let other people to do everything for me. I always have to do something myself. And this is what came out of it. So we have here a knowledge that the salt layer is about 150 meters below the surface. We have received a map of this salt layer. We have received drilling logs at 2 of these points. The salt layer that was given to us by the Swiss Salt Works shows that the layer is about 30 to 50 meters thick, and this knowledge has been interpolated from 8 boreholes. The location of electrical cables underground, the pipes for the water and for the brine, and the location of the existing brine caverns. This is what we have received as an information about what is underground, to compare it with the readings that we have made. Now, the report that resulted from the evaluation of these recordings, there's 99 pages. There's a long theoretical part. There are 17 quality control evaluations, whether the sledgehammer has actually hit the plate correctly, whether there is a clear seismic wave created, whether there is some background noise, whether there is some disturbance, for example, from a pipe or from a cable. Then there are 3 GPS locations for each point that we hit. There is the longitude, latitude, and the elevation. Then there are 24 electro-seismic and electro-telluric data renderings in the model. 3-dimensional model of the data renderings, salt layer profile, which was given to us by SaltWorks, is incorporated in the model. Then there is a detailed description and interpretation of the 24 data sets and 22 scientific references. These are the scientific references, and this is the model. This is what we have received, where we have seen, yes, whatever we have measured corresponds to what is known as a salt layer underground. This is the surface. And you can see that in the surface, this electro-telluric tomography actually records a change in conductivity. So if there is water here, and there is a brine here, and there is a change of conductivity between the two. And it shows as an electro-telluric response. So we have one here on the top. We think this is fertilizer in the field that changes its concentration on the top of the field. Then there is nothing, because this is all filled with Rhine water, and there's no change in conductivity. Then we have this layer here, which corresponds to the cap rock. The cap rock covers the salt to protect it against, or it protects it against dissolution if there would be no cap rock, consisting mainly of calcium sulfate, and just the water, then the salt would dissolve with time. And then afterwards we have similar layers of change of conductivity underneath. These are the underlying sedimentary formations. Now this is a cutout from a 3D model, and I would like to show you now the 3D model. And if we pick it up here and turn it around, we can see the layers more from the top or more from the bottom, or turn it around like this. Here we can see the layer of the changing conductivity covering the salt. If we move it a little bit more around like this, we see the known profile of the salt and the other layers. Okay? Now I will show you another view number 1, which shows where the water is. So here you can see that the whole geological formation above the salt is covered with water. This is the existing aquifer. We also see some water deposits below the salt, and here you can see some kind of response, but this response corresponds exactly to the cavity that is there. We did 30 points in one day. A bore hole takes about 2-3 days for this depth, perhaps even more. So you can imagine what kind of saving in time and in cost you can achieve with electro-seismic mapping of salt deposits. Thank you very much.
Thank you very much. Also, indeed, Vladimir, with still some question time from the floor, but before I give the floor the possibility to question, maybe I have a question. Is there any limitations to the system? Because I can imagine that having the production of the wave requires a certain energy. And is there any limitation in depth or in rock formation that would be delimitation for the energy that you have to apply?
You mean if I am too weak and I can't hit too strong? Yes, you are quite right. Manually down to about 400, 500, 600 meters, and otherwise below, let's say, 1 kilometer, certainly down to a depth of about 5 kilometers mechanically. This mechanical device is also very simple. It's a mechanical shovel with the rock breaker installed, the hydraulic rock breaker installed on it, on a bigger and thicker plate, and the hitting is then done with this hydraulic rock breaker.
And is there any rock formation that would also be a limitation to do that sort of systems that, for instance, grabs too much the energy before it can transfer to deeper depths?
No. No, on the contrary. These rock formations, such as granite, but you don't find salt on the granite, so it would have to be some kind of other stone. These are very conductive for the seismic waves, and they are certainly not an obstacle to the electromagnetic waves.
Okay. So questions from the floor? Any? One moment.
Thank you, this is very interesting. How is this different from the seismic studies done in oil field to explore oil and gas underground? Is it the same technology?
No, it is not. Seismic is listening to an acoustic response from the seismic wave. So you need a source, but the source is usually an explosive. And then you need a series of microphones which you have to install, and the whole wiring and so on and so on. It's much more complex and much more expensive than this.
Thank you very much. Other questions? The floor? Yes.
Yeah, thank you, Vladimir, for the interesting presentation. But then compared to the traditional seismic exploration, so the amount of effort is apparently less. But in terms of type of information and quality of information, are there any differences on the accuracy?
I think yes. The seismic is always two-dimensional. Yeah? Here you have the source, here you have the microphones, and the interpretation is two-dimensional. Yeah? Well, I think the most important point here to understand is that most of the rock formations, particularly those that are wet in some form, give an electromagnetic or electro-telluric response, but the rock salt doesn't. What you have seen here as salt layer, there is no response. So, you get all kinds of information about what is above the salt layer, then you have a void, which you interpret as salt on the basis of one core rock. And then you are mapping the form of the salt layer.
Thank you, Vladimir. You mentioned it takes a lot less time and a lot less people, but what would be the cost compared to a standard seismic survey to do a similar mapping?
Okay, this question I was expecting, however, I cannot answer it by now fully. We have introduced this by emailing activity just a couple of weeks ago, 1 week ago. We have received inquiries. We are making estimates of this cost, and the clients will, of course, show us what the cost of the other methods that they have and that they are looking at is, and that will give us the answer, that will give us the information that we can then again publish and to show, in so many percent or under such circumstances the cost looks like this. We are not yet at this stage.
Okay, thank you very much.
However, if you see an application somewhere or among your people whom you know, then we would be extremely interested to find out how much more competitive this will be.
Het heeft in ieder geval iets.
Immer wenn wir in Kamers